Hello everyone. This side Mayank Jhunjhunwala from IIT Kanpur. Yesterday we discussed matrices and determinants chapter, but yesterday our focus was on the theory part, and today we will do some questions on so that you can practice them. So now let's start. Transpose of a matrix, the determinant, properties of determinant, Laplace formula, all these things we discussed yesterday. So today we are gonna do some questions on these concepts. I told you how to calculate adjoint and how to solve simultaneous equations using matrix method. This is very important for JEE Mains, especially how to solve linear equations. Then system of consistent equations we also studied yesterday, where we tried to solve three linear equations by using the formula of x equal to a inverse b, where a inverse is adjoint A upon det A. So all these things were important. So now let's start with some new questions. So the question is saying what? The roots of the equation 1, 4, 20, 1 minus 2, 5, 1, 2x and 5x squared equal to 0 are what? So basically I have been given with a determinant and they are asking me to solve this and calculate the value of x. So either you can do it directly opening the determinant, or you can even manipulate the values so that you can make some values to be 0 and then open it so that your calculation will be easy. So what I did basically is I yesterday told you that in any determinant, whenever you want to solve a determinant, you can do row or column operations where you can replace a row by subtracting it with another row. So like here also, what we can do is we can replace R1 by R1 minus R2 and R2 by R2 minus R3. So by replacing such, what we are doing is we are trying to make this A11 and A21 equal to 0 so that when I will open the determinant, these two values will be my 0. So I need not to open them for these two values. I just need to open it for this one. So when I will open it for this one, I know that this is positive only, positive, negative, positive. We know that it is alternate plus minus, that's why. So now let's open it against this A31. So it would be 1 times, neglect this row and neglect this column. And what will be left is 1 minus x square minus this thing, which is minus of minus times 1 plus x. So it would be plus 1 plus x. So at the end, what we are getting? We are getting 2 minus x square plus x equal to 0. Now it is a simple quadratic equation. We can easily solve it. X square minus x. And we know that we can convert it into x plus 1, x minus 2, because x is equal to minus 1 is the root of this thing. Minus 1, uh, here we will get 1, here we will get 1. 1 plus 1 minus 2 is 0. So basically, two roots, minus 1 and 2. So from here, we are getting two values of x, which is minus 1 and 2. Basically, determinant simply get a quadratic equation, then solve it to get the values of x.
Recording in progress.
reduce the expression. Initially, it was in terms of A and B. Now it is in terms of B only, so that we are getting a nicer expression. So that's why just convert it into R2 minus R1 and R3 minus R2, and you will get this final determinant equal to 0. And I told you yesterday how to solve this. This is very simple. You have to just calculate the value of this determinant only, na. So now it is up to you. You can take the values of A and B according to yourself, because you need to calculate the value of determinant, and the value of determinant depends upon you only. So if you will put A equal to B equal to 1, you are getting answer to be equal to 0. And since you are getting equal to 0, then it will be 0 for any A and B. You can even solve it by without putting the values, then also you will get 0 only. But putting A equal to 1 equal to B will make your answer simple, because now you need to play with the numbers, not with the variables of A and B. Playing with variables may cost you extra space, extra time, which you might not want to expand in your paper. So you can simply put the values and then calculate your answer. Since you are getting 0, so if you will be doing with variables also, you will get 0 only. So this is a, you can say, a trick to solve this question, but this will save your time. Okay, then moving on to question number 7. Question number 7 is a PYQ actually. It was asked in JEE-Mains. I think 2020 it was asked. So it is like the same thing. You have to evaluate this determinant, but there you can see that there is a symmetry of squares. Like every term is squared, a square, b square, c square. In every term, you can see the square only, and you now need to calculate the value of this delta. Delta is nothing but determinant only. So to calculate the values, you know that you can see that here it is b square plus c square, and it leave everything. You just need to find symmetry. You can see here it is b square plus c square, and here it is b square, here it is c square. So if you will subtract these two with this thing, you will get a 0, and you need 0 only so that you can evaluate the determinant. So just do the same thing. Put r1 equal to r1 minus r2 minus r3, so that you will get 0 here, and the rest will be obviously a square minus c square minus a square minus c square, so minus 2c square. Similarly here minus 2b square. Now just open the determinant across this thing. You will get your final answer as 4a square, b square, c square. You can even open it directly. Just we do these type of things to simplify our calculation, nothing else. Because determinant chapter is simple, it is just time consuming. So you need to be smart while solving these type of questions, otherwise it will cost you a lot of time. So it was pretty simple. Now this question is not tricky one, but you need to use your brain. If minus 9 is the root of the equation, then the other two roots are what? Basically मेरे को एक determinant दिया हुआ है, and we need to solve this determinant, and obviously बात है क्योंकि determinant में x दिया हुआ है. So after solving the determinant, what I will be getting some equation in terms of x only. So उस equation का मेरे को एक root दिया हुआ है कि minus 9 is the root of that equation, and I need to tell the second root. Cool. सो बेसिकली मेरे को दिख रहा है कि जब मैं इसको मल्टीप्लाई करूंगा, तब मेरे को एक रूट माइनस साइन मिल रहा है, तो मतलब x+9 इक्वल टू 0 इसको सॉल्व कर देगा बेसिकली. तो लेट मी डू द सेम थिंग. We can take, okay, let's open it directly. Forget all these things and open it directly. It will be very much easier. X times x square minus 12 minus 3 times 2x minus 14. 2x minus 14 plus 7 times 12 minus 7x. 12 minus 7x equal to 0. So from now you can simplify it. You will get x cube minus 12x minus 6x, which is minus 18x. Obviously, it is plus 42. Then plus 84 minus 49x equates to 0. So on further solving, you will get x cube minus 18 minus 49. It would be minus 67 minus 67x plus 126 equal to 0. Simple. They have been given that minus 9 solves this. So we know that the minus 9 cube is nothing but 729 minus 729. So minus 729, and here we will be getting what? We will be getting plus 3, 6, 9, 6, 9, 6, 54, 54 and 6 is 60. So plus 603 plus 126. Let's check if we got the right equation. So 9, 2, 7. Yeah, it is coming out it to be equal to 0. So this is my correct equation. So now it's simple. Just divide this equation by x plus 9. You will get the other two roots, x minus 2 and x plus x minus 7. From there, you can say that the other two roots are 2 and 7. Okay. So just now divide this equation, which is x plus 9. This is my divisor, divided by x cube minus 67x plus 126. So you can simply write x square, then x cube plus 9x square. Here it will cancel, and you will get minus 67x plus 126 minus 9x square. Now do minus 9x. So you will get minus 9x square minus 81x. So this will cancel, and here it would become plus. So 81 minus 67 is how much? 77. And then 14. So 14x plus 126. So basically, just now add 14, and you are getting your answer 14x plus 126. Now it will cancel, and you will get your answer as 0. So this is the my quotient, x square minus 9x plus 14. This is my quotient. Now you can just open it. How will you do so? You will take x square minus 7x minus 2x plus 14 equal to 0, and you will get x minus 2, x minus 7 equal to 0 as your final roots. So the final other two roots of this equation are 2 and 7. So you see, you just need to calculate the determinant of uh, the given determinant, and you will get a equation. You will get a cubic equation. That divided cubic equation by x plus 9, because you have been given that minus 9 is a root. You will get something like this, and from there, this is again a quadratic equation, and you can solve it. Simple. I guess it is simple. So आगे चलते हैं. If ABC are unequal, what is the condition that the value of the following determinant is 0? Okay, so they are saying basically कि मेरे को again एक determinant दिया हुआ है, and the values of A, B and C are unequal basically. Then the value of determinant is 0. उसके लिए क्या कंडीशन होगी मुझे वो बताना है बेसिकली. ठीक है, तो यहाँ पे भी डिटरमिनेंट की प्रॉपर्टीज यूज करेंगे अपन लोग. डिटर्मिनेंट की प्रॉपर्टीज होती है कि जब मेरे को किसी भी एक कॉलम या एक रो में एडिशन के फॉर्म में दिया होगा, then what I can do is I can separate this determinant into two determinants. In those two determinants, my first two columns will remain same. You can see 111 ABC. They have taken basically ABC common, nothing else, and 111 ABC. So when you will take ABC common, you will get this thing only. So basically, what they did is, firstly they took A common from the firstly separate both these determinants. You will get A, B, C, A square, B square, C square, then A cube, B cube, and C cube. These are my determinants. Then add it to A, B, C, A square, B square, C square. And since it is added to 1, so next three terms would be 1 only. This is also a property of determinants that you can separate them. Okay? So it is A, B, C. Okay? Now take, now what you can do is, take ABC common, like take A, this is nothing. Take ABC common from each row. So take A common from first row, B common from second row, and C common from third row. So you will get ABC 1 A square, 1 B square, and then 1 C square, plus what you can do here is, you have to write it directly because you are getting nothing common. So write it directly. A square, 1 B square, 1 C square, 1. Okay. Now it is simple. You just need to convert this determinant to this determinant. How can you do so? Okay, change these two rows. Now you will get A square, B square, C square here and ABC here, and then change these two rows. So basically, if you will do even number of changes, the value of a determinant remains same. This is also a property. If you do the even number of changes in the row or even number of changes in the column, then the value of determinant remains same. So just replace first two rows, first two columns basically, and then replace first column with the third column. So A square, B square, C square will come here, and then it will go there, and 111 will finally come here, and ABC will uh, occupy the middle column. So basically you are doing even number of changes and you are converting this determinant into this one so that you can take this thing common, and you will be left with 1 plus ABC, 1 plus ABC multiplied by whatever, when you will evaluate this determinant, you will get this thing A minus B, B minus C, and C minus A equal to 0. So now what you need is the if A, B, C are unequal. Since A, B, C are unequal, that's why it was given here. If A, B and C are unequal, so A minus B will not be equal to 0. Obviously बात है. अगर A, B unequal है, मतलब अगर same नहीं है, then how can A minus B be equal to 0? So A minus B is unequal. A minus B is not equal to 0. Similarly, B minus C is also not equal to 0. Similarly, C minus A. So only your 1 plus ABC can be equal to 0. So this implies that the condition for determinant to be equal to 0 is ABC should be equal to minus 1. This is my answer. Cool? कल था देखो, इसमें भी आपको डिटर्मिनेंट सॉल्व करना था. अगर आपको डिटर्मिनेंट की प्रॉपर्टीज अच्छे से आती है, then you can do it. Now moving on to next question. Again, you have to solve determinants. So let's do this question now at the end if we are left with time. Now let's cover the other concepts. Okay, let's do this one because this is of complex numbers. वैसे करना कुछ नहीं है इसमें भी आपको वही डिटर्मिनेंट ही खोलना है. Take 6 iota, then evaluate this determinant. It will be 3 iota square. Iota square is -1, so -3 plus 3, so it would be equal to 0. So basically ये चीज तो कैंसिल हो गई. फिर प्लस 3 iota क्योंकि माइनस माइनस प्लस हो जाएगा. 4 iota plus 20. 4 iota plus 20 plus 1, 12 minus 60 iota. This thing is equal to x plus iota y. So basically यहाँ से क्या मिल जाएगा 12 iota square. That will again be equal to -12. -12 plus 12 cancel. And 60 iota minus 60 iota cancel. So x equal to 0, y equal to 0 is my correct option. So option B is the answer. Simple. ठीक है. जो simple question था. Just evaluate the determinant and compare the values of real part and imaginary part. ठीक है. Okay, let's solve this one also. Basically, you have been given with the value of omega. Omega is nothing but the cube root of unity, which is represented by -half plus iota 2 3 by 2. Omega square is the complex conjugate of omega, which means omega square is nothing but just replace this plus sign with a minus sign. You will get omega square because cube roots of unity are 1, omega, and omega square. And the properties of cube roots of unity is 1 plus omega plus omega square is equal to 0 and omega cube is equal to 1. ठीक है. और ये तो पता ही है कि ओमेगा बार is equal to omega square. These are the properties of cube roots of unity. So मेरे को ये वाला determinant दिया हुआ है. So basically मैं क्या कर रहा हूँ, मैं I need to make these two values to be 0 equal to 0. So अगर मैं basically मैं क्या कर रहा हूँ, let's do one thing. We can either make it equal to 0 and we can directly open it. Directly opening it will also not give us any problem because this is 1 1 1 only. So let's open it directly. So you will get minus omega 4. Firstly, do one thing. Change it into simpler values of omega. So you will get 1 1 1 1 1 minus 1 minus omega square. We know that minus 1 minus omega square is equal to omega. So this would be omega. Then omega square, make it omega square only. Omega square and omega 4 is equal to omega. I told you that omega starts repeating its values after every 3 cycles. That is, omega 4 is equal to omega because omega cube is 1. So you will get something like this. Now open it simply. You will get omega square minus omega power 4 minus 1 times omega minus omega square. Omega minus omega square plus 1 times omega square minus omega. So basically you are getting omega square plus omega square, which is 2 omega square minus omega 4 minus omega. So minus omega 4 is omega only. So minus 2 omega. And here it is plus omega square minus omega. So basically 3 times. And remove this. So you are getting 3 omega common, omega minus 1. This is your final answer as shown here. Okay. Again, a simple one. Just you need to evaluate the determinant. Okay, the number of values of k for which the system of equations k plus 1x plus 8y equal to 4k and this equation has infinitely many solutions. So मैंने आपको बताया था इसको मैं सॉल्व करने के लिए एक मैट्रिक्स मेथड यूज करता हूँ जहाँ पे मेरा x आता है where I get my x equal to a inverse b, a inverse b. ठीक है, तो ये होता है मेरा x. अब मेरे को पता है इनफाइनाइट सॉल्यूशन के लिए क्या केस होता है, मैंने बताया था. मैं a इनवर्स को ओपन करूंगा. a इनवर्स इज नथिंग बट adjoint a अपॉन det a. adjoint a अपॉन det a मल्टीप्लाइड बाई b. ठीक है, सो अब यहाँ पे मैंने बताया था अगर मेरे को इनफाइनाइट नंबर ऑफ सॉल्यूशंस चाहिए तो मेरा det a शुड बी इक्वल टू 0 एंड adjoint a into b शुड बी इक्वल टू 0. सो बेसिकली बताया था कि इनफाइनाइट नंबर ऑफ सॉल्यूशंस का मतलब होता है कि मैंने एग्जांपल भी दिया था. लेट्स से 2x प्लस 3y प्लस 4z equal to 7. Let's say one equation is this, then second equation would be something like this: 4x plus 6y plus 8z equal to 14. Basically जो मेरी दोनों इक्वेशन है वो सेम होती है, just this equation is a multiple of this equation. If you will multiply this equation by 2 you will get this equation. So the ratio of terms would be same, that is 2 by 4 is equal to 3 by 6 is equal to 4 by 8 is equal to 7 by 14. You can see that each term is equal to half. So that's what we can do here. We can simply write k plus 1 upon k equal to 8y. So 8 upon k plus 3 equal to 4k upon 3k minus 1. Okay, now it is simple. You can just open this and you will get a quadratic equation in this form. So you will get this equation and this equation. Now you can solve this two quadratic equations to get the value of k. Obviously we need to take the common value because अगर मैं 3 लूंगा तो फिर वो इस इक्वेशन को सेटिस्फाई नहीं करेगा, 2 लूंगा तो इस इक्वेशन को सेटिस्फाई नहीं करेगा. So common value of k is 1, so k equal to 1 is my final answer. So basically the number of values of k for which the system of equations is infinitely many solutions is 1 only, which is also equal to 1. Cool. Simple question, just compare the coefficients of both the equations. You will get two quadratic equations, take the common value, that common value is your answer. Okay. Moving ahead. Let M be any 3 cross 3 matrix. Okay. मैंने कोई 3 cross 3 matrix ली M with entries from the set 0, 1, 2. So I basically took a matrix 3 cross 3 from the entries would be from 0 and that is A, B, C, D, E, F, G, H, I can either be equal to 0 or 1 or 2. The maximum number of such matrices for which the sum of diagonal elements of M transpose M is 7. Okay, तो basically एक मैट्रिक्स मैंने M ये मानी कोई भी मैंने मैट्रिक्स में मान लिया और फिर मैंने उसका ट्रांसपोज दे लिया। ट्रांसपोज के लिए मैंने आपको बताया था रो और कॉलम इंटरचेंज कर दो। रो शुड बी इंटरचेंज विद कॉलम्स। सो ए डी जी ऐसे आ जाएगा, बी ई एच ऐसे आ जाएगा, और सी एफ आई ऐसे आ जाएगा। ठीक है। सो नाउ लेट मी इरेज इट फॉर बेटर क्लैरिटी। नाउ what they're saying is you have to multiply m with m transpose. So let me write m transpose here only so that we can multiply it. A D G D E F G H I. This thing is equal to, simply multiply, you will get a square. Just write the diagonal elements because you need the sum of diagonal elements only. So why you will write the other elements? So just write diagonal elements. You will multiply this thing by this thing. So first row with first column, second row with second column, and third row with third column. We basically for second row and for third row. मतलब basically first row with second first column for first element, then first row with second column for second element, then first row with third column for third element. Now second row with first column for this one, second row second column for this one, second row third column for this one, and similarly for third row. So a square plus bd, a square plus I did something wrong, a b है यहाँ पे, a square plus b square plus, I don't know why I wrote that thing wrong. It is also c, adg, then beh, then cfi, beh, cfi. I guess I don't know why I wrote it wrong, but okay. A square plus b square plus c square. This is my first diagonal element. Then to get this diagonal element, I need to multiply second row with second column. So I will get d square plus e square plus f square. And then I will do same thing for the third row and third column. I will get c square plus, no, c square, it is g square plus h square plus I square. So basically the sum of all these 9 quantities is equal to 7. So from there I got this thing, a square plus b square plus c square plus d square plus e square plus f square plus g plus h plus I equal to 7. So now what you need to do is you need to find maximum number of such matrices. So basically मेरे को पता है कि जो a, b और c की जो entries है, that can only come from these three elements which are 0, 1, 2. अब अपने को देखना है कि अपन लोग 0, 1, 2 के कितने कॉम्बिनेशन ऐसे बना सकते हैं कि मेरे को सम करके 7 मिल जाए। तो बेसिकली क्योंकि मेरे को सबका स्क्वायर लेना है, सो आई नीड टू डील विद 0, 1 एंड 4। ठीक है। तो मैं ऑब्वियस सी बात है कि क्या तो मैं 0 ले सकता हूँ, क्या तो मैं 1 ले सकता हूँ, क्या तो मैं 4 ले सकता हूँ। बट अगर मैंने एक भी एलिमेंट को 2 ले लिया तो फिर मैं दूसरे एलिमेंट को 2 नहीं ले पाऊंगा क्योंकि फिर वो 4 और 4 8 हो जाएगा, दैट इज इट विल एक्सीड 7। सो आई कैन टेक 1, 2 and then 3 ones, and remaining quantity is 0, which means 9 zeros. This is PNC only, so you need to do it So this is one combination. So basically now you need to arrange these 9 elements in these 9 A, B, C, D, E, F, G, H, I. So basically there are 9 elements. So arrangement we study in PNC. It is 9 factorial upon how many zeros? 5 zeros. So 5 factorial, and how many ones? 3 ones. 3 factorial. How many twos? 1 2. So 1 factorial is 1 only. So this is the thing for this combination. And now there is one more combination. If I take 7 ones itself, I will not take a 2 and I will take 7 ones. So 7 ones and 2 zeros. 7 ones and 2 zeros. So यहाँ से क्या मिल जाएगा मुझे? From here I will be getting 9 factorial, because in total there are 9 elements, divided by 7 factorial into 2 factorial. So add both these two quantities, you will get your final answer. And your final answer is coming to be 504 plus 36. That is equal to 540. So I think 540 is my final answer, which is written here. Cool. So जो आपको बोला गया अपन लोग वो करो. पहले आपको मैट्रिक्स दी हुई थी. Take the matrix. Then you have been said to calculate the transpose. Calculate the transpose. Then multiply. Multiply. After multiplying, you are getting sum of 9 squares equal to 7. So just basic PNC. You need to make 7 by 0 and 4. Make it, and the number of combinations, add them. You will get your final answer. Okay. So now moving on to next one. Okay. Then if for the matrix, question is saying if for the matrix A equal to 1 alpha minus alpha beta, A transpose is equal to I2. Here, what is I2? I2 is nothing but the identity matrix only. So I2 is equal to 1, 0, 0, 1. This is my identity matrix. Okay. So you have been given that A into A transpose is I2. So write A into A transpose. A into A transpose क्या होगा ये? ये हो जाएगा 1 minus alpha, alpha, beta, 1 minus alpha, alpha, beta. Actually, I need to write the transpose. So I need to remove negative signs. Okay. So this thing is how much? This is equal to 1 plus alpha square, 1 plus alpha square, then alpha minus alpha beta. So take alpha common. Alpha into 1 minus beta. 1 minus beta. Then alpha plus alpha minus alpha beta. So you can write it alpha common 1 minus beta. And then finally alpha square plus beta square. This thing is given to us equal to I2. So this thing is equal to 1, 0, 0, 1. So from here you are getting the value of alpha square plus 1 equal to 1. So alpha is equal to 0. Alpha is equal to 0. Similarly, alpha square plus beta square is equal to 1. So beta is equal to plus minus 1. But I need to check this. So take this equation, alpha is equal to 0 only. So this thing is 0. Okay. So basically, I am getting the value of alpha to be equal to 0 and beta to be equal to plus minus 1. So I need to tell the value of alpha power 4 plus beta power 4. So 0 plus beta power 4 will be 1. So my answer is 1 because this is 0 and this is 1. So 1 is the final answer. So A part is correct. Just calculate the values of A and A transpose, then equate it to I2. You will get simple equations, and you can, from these simple equations, you can calculate the values of alpha and beta, and you will get your final answer as 1. Next one now. Let A be a symmetric matrix of order 2 with integer entries. Okay, then again now they are only integer entries. If the sum of diagonal elements of A square is 1. Okay, then the possible number of such matrices are how much? So again take a matrix A, B, C, D. But since it is a symmetric matrix, so you know in case of symmetric matrix, this and this element would be equal. So A, B, B, C, because you know a symmetric matrix implies A is equal to A transpose. And you know in transpose, these elements will reverse, diagonal elements will remain same. So if A and A transpose are equal, so these two elements need to be equal. Then multiply A by itself, you will get A square plus B square, then AB plus BC, then AB plus BC again, and finally B square plus C square. You are getting this thing as your A square. Okay, but in question it is given to you that the sum of diagonal elements of A square is 1, which implies A square plus 2B square plus C square is equal to 1. And since the entries are only integers, so you can either fill 0, 1 or minus 1, because anything else will make it bigger than 1 because you are doing square. So if you will take 2 or minus 2, then it will take it to 4, and then you can't make it 1. So basically you have only 3 entries, 0, 1 and minus 1. Otherwise you will not get 1. Now from using 0, 1 and minus 1, you need to form 1. So either use 2 zeros and 1, or you can use, oh, okay, you need to use this thing only, the 0, 0, 1 or 0, 0, minus 1. These are the two possibilities. In these two possibilities also, there is a catch that you can't use b equal to 1, because if you will use b equal to 1, then it will multiply by 2 and you will get 2. So basically, values of a and c can be equal to plus minus 1. Okay, so there are total 4 such matrices, and those 4 are A, B, C. Let me write the 4 cases. You can take the value of A to be 1, it has 2 zeros, and then A can be minus 1, it has 2 zeros, then these two can be 0, C can be 1, or finally 0, 0, minus 1. These are the 4 situations. For these 4 situations, your condition will be satisfied and you will get the sum of diagonal elements of A square to be equal to 1. So A square plus 2B square plus C square equal to 1. In in only these four cases. So your answer would be equal to 4, which is the C part. Okay, moving on to next one. The total number of 3 cross 3 matrices A having entries from the set is 0, 1, 2, 3. Again, entries are from 0, 1, 2, 3 only, such that the sum of all the diagonal elements of A transpose is 9 is equal to how much? तो basically मेरे को मैट्रिक्स दी हुई है A और वही चीजें जैसे कि उस वाले केस में मेरे पास था कि सम 7 होना चाहिए. यहाँ पे मेरे को बोला गया है कि सम शुड बी इक्वल टू 9 एंड जस्ट द सेम. बट in that question you were having 0, 1, 2. In this question you are just needing one more variable, which is 3. So you need to make 9 by using 0, 1, 2, 3. So I will just write the cases because this is the same question, just an enhanced version of that one. So you can make 9 by either taking 1, 3 and the rest zeros, which means 1, 2, 3, 4, 9 zeros, 8 zeros and 1, 3. 8 zeros and 1 threes, or you can take 2 twos, so you will get 4 plus 4, 8, and 1, 1, and rest 6 zeros, or you can take 1, 2, and you need to make 9 na, so 5 ones and 5, 6, 7, 2 zeros, and the last case would be taking all ones, so 9 ones. These would be my 4 cases. Now you can arrange these 4 cases in the same way. 9 factorial upon 8 factorial. In this case, it would be 9 factorial upon 2 factorial, 6 factorial. Those which are repeated, you need to divide them. So again here 9 factorial upon 5 factorial, 2 factorial. And in this case, there is only one case, so it would be 1 only. So 9 factorial upon 8 factorial, 9. 9 factorial upon this thing is equal to 252. Then 9 factorial upon 5 factorial, 3 factorial. 5, 6, 7, 8, 9. Okay, with 3. So 9 factorial upon this thing is equal to 504. So total there would be 1 plus 9 plus 252 plus 504, which is 766 matrices. So in total, you would be having 766 matrices, which will satisfy this condition of A into A transpose equal to 9. Moving on to the last question. In this one, it is saying A is a column matrix with only two elements A1 and A2, and B is also a column matrix with two elements B1 and B2, 2 cross 1, then such that A is equal to X times B. A is equal to X times B, and X is given to you. Then if A1 square plus A2 square is this thing, B1 square plus B2 square, and this thing is, मतलब मेरे को तीन condition दी गई है, and they are asking me the value of K. So basically I need to tell the value of K by using these three conditions. Okay, so again a simple one. Firstly, multiply x with b so that you can get the value of xb. So you are getting this equation. Now equate the values. You will get b1 minus b2 equal to root 3 times a1 and b1 plus k b2 equal to root 3 times a2. So these are the two equations. One second. So you are getting these two equations. One is this and second one is this one. Then you know that b1 minus b2 can be written like this. This is nothing but b1 minus b2 whole square. b1 minus b2 whole square is equal to b1 square plus b2 square minus 2 times b1 b2. This thing is equal to मतलब मैंने दोनों तरफ square कर दिया. So this square is equal to this square which is equal to 3a1 square. So I got this equation by squaring my first one. Then this is my second one. So again square this one. You will get b1 square plus k square times b2 square plus 2 times ab, which is 2k b1 b2 is equal to 3a square. So basically now you got these two equations. You got these two equations. This one and this one. Now in the question it is given to you that a1 square plus a2 square. Since they are saying you a1 square plus a2 square, so you can add both these two equations. 3 will become common and you will get a1 square plus a2 square. So adding first and second, you will get 3 times this 3 and this 3 will cancel. You will get 2 times b1 square plus b2 square, 2 times b1 square plus b2 square equal to b1 square plus b2 square 2b1 square plus b2 square k square plus 1 plus 2b1 b2 k minus 1. From here 2b1 square will cancel and you will be left with this equation k square minus 1 times b2 square plus 2b1 b2 k minus 1 equal to 0. So from here either b2 is equal to 0. This is one case. But they're saying that this thing is not equal to minus 2b1 b2, which implies क्योंकि अगर मैं k minus 1 को 0 नहीं करूंगा then I will say that k square plus 1 times k square plus 1 times b2 square is equal to okay. I am saying that this thing is not equal to minus 2 b1 b2. So this is given to me in question. So only this thing is left. From here, if I will say b2 equal to 0, then this condition will satisfy. But they're saying this is not equal. These two are not equal. But if I will take b2 equal to 0, then these two will become equal. So b2 is not equal to 0. So what is remaining? Only k minus 1 is remaining, which implies k minus 1 is equal to 0. Then only this condition will be satisfied, otherwise not. So from here, you can directly say that your value of k is equal to 1. Because if you will make b2 equal to 0, then this condition will be neglected because b2 equal to 0 will make both to be equal to 0. But they are saying it is not equal. So you can't take b2 equal to 0. You can only take k minus 1 equal to 0. From there, k equal to 1, you are getting. So if you need that a should be equal to x times b, so K should be equal to 1. This is the final condition so that this will be satisfied. Otherwise not. Okay. So this was the final question of our matrices and determinants revision. I hope you got it, but just try to revise these concepts again and again, especially the concept of adjoint and simultaneous linear equations, because those are those concepts which are asked again and again in JEE-Main especially. So now let's wrap up the session. Thank you.